We are starting a new unit and we are going to be dealing with radicals. Now, radicals is a large topic that includes anything that will undo an exponent, right? So addition will undo subtraction, multiplication will undo division. A square root or a radical of any type will undo an exponent. We are going to be focusing on a square root, which is the inverse operation of an exponent of 2. Okay, so we're going to be in this basic square root and not spend time in all of the other radicals. We're just going to know that they exist. So we'll undo an exponent of 3 with the cube root and so forth. Okay, we have some straightforward square roots that we've already talked about because we've been factoring special cases. Okay, so we have our perfect square roots. And those are numbers that we can just type in a calculator or use our brain and think of a number times itself. So for example, we know that the square root of 25 is 5. Why? Because 5 times 5 is 25. Now, if you're like, oh man, I really didn't know that that's what it was, or I'm not good at finding those, right? Our calculator can calculate a square root for us by hitting second x squared, right? Well, the square root button is right in that lighter writing above the x squared. And then we see the square root symbol show up. We'll put in 25 equals. Okay, and it tells us 5. Now, we could do this for small numbers. We can do it for large numbers. So let's say we want to take the square root of 729. Like, okay, I don't know what the square root of 729 is. So we'll put that in our calculator, right? Second x squared, 729 equals 27. Okay, we can do it even if the number looks kind of weird. So maybe we want to do the square root of 9/25. Right, we can still just do that in our calculator, right? So second x squared, 9 ABC 25, and it will tell us 3/5. Okay, unfortunately, everything is not a perfect square, right? So if I want to do something like the square root of 40, if I put that in my calculator, I get this big old long decimal out. Okay, it's not a perfect square. In fact, it is an irrational number. It is a decimal that will go on for forever. So we can't even write it down without rounding it. So we need to have some other ways of dealing with these square roots that are not perfect squares. And the way that we are going to deal with them is we are going to start by being able to simplify them. Okay, and simplifying a square root is the same idea as simplifying a fraction. We could write down 4/8, but in simplified form, we're really talking about 1/2. And we do that so that everybody's talking about the same number, right? Instead of one person having 1/2 and someone else having 2/4 and someone else 3/6 and someone else 4/8, right? We all get it in its simplest form, so we have this one agreed upon way of writing it. The square roots that are irrational, right, that aren't these perfect squares, are the same way. If we can get them simplified, we want to do that so that we're all talking about a number in its same format. And the way that we are going to do that is by prime factoring. Okay, so our first step is going to be to prime factor 40. And we've already talked about prime factoring, so we're going to split this up into its factor tree. I'm going to pick 4 times 10, but again, you could pick anything that works. 4 is going to split into a 2 times a 2. 10 is going to split into a 2 times a 5. Okay, so I now know for my prime factorization of 40, I have 2 times 2 times 2 times 5. Okay, and now I'm going to think about this in a different way. Since this is the same thing as 40, just written in a different format, I now have the square root of 2 times 2 times 2 times 5. Okay, my second step is going to be to find pairs. Now, I'm putting pairs here kind of in quotes because If this was a cube root or a larger root, if it was a cube root, we would find triples. If it was a fourth root, we would find quadruples. So this works for any type of radical. But again, we're just going to be focusing on square roots, so we're going to be looking for pairs. So if I look underneath here, I see a pair of 2's. So I'm going to circle that. In my third step, I am going to pull my pairs in front of the square root. Now, here's the thing. When you go outside of this square root, this is one pair that I circled, right? You have 2 shoes, but it only counts as one pair. So while I circled 2 2's, as soon as I come outside of this square root symbol, I'm only going to write it down one time. Okay, and the very specific reason why is that 2 times 2 is 4, and the square root of 4 is 2. Okay, so that's allowed to come outside. Anything that doesn't have a pair stays inside. And then for my last step, I'm going to multiply numbers in the same location. Okay. So anything that's in the same location is going to get multiplied. So inside stuff will get multiplied together, and outside stuff will get multiplied together. Now, there's nothing else outside with this 2, so that just stays as a 2. 2 times 5 is 10. So my simplified answer is 2 square root 10. Now, if we don't have to write down those steps in between, okay, it takes a little bit less work maybe to do it. So let's say we want to do the square root of, how about 360? Making sure I was going in the right order with my notes. So step 1 tells us to prime factor. So I'm going to take this 360 and I'm going to start splitting it up. Again, it doesn't matter what you pick. If all you see is that this is even and you pick a 2, pick up your calculator and do 360 divided by 2. I'm going to pick 10 and 36. When it ends in a 0, I always pick a 10. Because then I get some smaller numbers that look a little bit better to me. 10 goes into a 2 and a 5. 36 I can do in a 6 and a 6. 6 goes to a 2 and a 3, and a 2 and a 3. Okay, so remember, everything at the bottom of the tree is what counts. Anything that doesn't have a branch coming off of it. Okay, we also said when we primed factored, we didn't have to write it in numerical order, but it'd be really handy if we did. Here's why. Okay, so I'm going to write down numerical order 1, 2, 3, right? That gets my 2's. I have a couple 3's, and then I have a 5. Okay, so I'm going to circle my pairs. That's my next step. Okay, so now that I'm in this format, I'm going to look for any pairs. So I have a pair of 2's, and I have a pair of 3's. Anything that I circled, I'm going to bring out in front. And when I bring it out in front, it only counts one time. So that 2 is coming out in front, a 3 is coming out in front, a 2 and 5 are left over. Okay, anything in the same location, I'm going to multiply. 3 times 2 gives me a 6. 2 times 5 gives me a 10. And so my final answer is 6 square root 10. Okay, it doesn't matter how large these numbers get, you're going to use the same process every single time. So even if you go, okay, I have a ginormous number, I'm just going to be a little bit ridiculous here. How about 4,725? Okay, the process is the same. It's fine. Just use your calculator. So I'm going to go, okay, this ends at a 5, so let's see if I can divide by 5. Yes, I can. So 945. 189, right? I'm not going to finish this problem all the way out, okay? But you can still, even if the number is ginormous, tiny, right? You just have to keep going. If you get to something and you're not sure, like you might just have to guess. Oh, yep, that is divisible by 3. Okay, so always making sure you're just breaking it down and prime factoring as far as you can. Last thing I want to look at then is what happens if there's already something sitting out in front. So what if we have something like 2 square root 48? Okay, the process does not change here either. We are still just going to focus on what's inside the square root, and we are going to prime factor inside the square root. So 48, I don't know, maybe I'll do 2 and 24, 2 and 12, 2 and 6, 2 and 3. Okay, so 1, 2, 3, 4 2s, and a 3. Now I'm just going to leave this, that number was outside, so I'm just going to leave it outside. Okay, I'm going to do the same idea with finding my pairs. And any pair is coming out in front. Okay, when I bring it out in front, it counts 1 time. So this 2 comes out. This 2 comes out. That 2 was already out. And a 3 is left inside. I'll multiply anything in the same place. So 2 times 2 is 4. 4 times 2 is 8. And my final answer will be 8 square root 3.